Oscillating reactions are a great way to grab students' attention. They also make quite interesting open day demonstrations. There are quite a number of different oscillating reactions, different choices that you could make, but this one, although it doesn't have the most spectacular colour change, is one of the simplest ones to do. I'm going to start by making a solution of sulfuric acid, and I'm going to do this by taking 75 cm cubed of the concentrated acid and add it to 750 cm cubed of distilled or deionised water. It gets quite hot as you add the acid, so add it a little at a time with stirring. Remember always to add acid to water, not the other way around. Or as a colleague of mine says, remember that you ought to add acid to the water. And it's quite important to use distilled or deionised water because even just a trace of chloride ions can actually inhibit the oscillation reaction. And then we're just going to leave that to stir and cool back down to room temperature. Also before the demonstration, it's worth pre-weighing the solid reactants that you're going to need. And you'll need to weigh out 9 grams of malonic acid, also called propane dioic acid, 8 grams of potassium bromate 5, and 1.8 grams of the manganese 2 sulfate. You need to do the next stage on a magnetic stirrer. So add the follower to the sulfuric acid solution and set the stirrer speed so that you create a vortex in the centre of the solution. You'll add the solids one at a time, and to show the colour change more easily, it's good to have a white background. First add the malonic acid and the potassium bromate. And leave that to stir for just a few minutes until they've completely dissolved. Then add the manganese sulfate. And almost immediately you get a red colour due to the bromine. After about a minute or so, the colour will disappear. The reaction will now oscillate back and forth between red to colourless, red to colourless, for about another 10 minutes, which is probably long enough for most audiences to lose interest. The time period of the oscillation gets longer and longer as each oscillation goes on. But it oscillates around about 20 seconds. The oscillation is actually due to 2 autocatalytic reactions going on, but there's no really easy way to explain the chemistry. One way that you could try to explain it is to use a predator-prey analogy, say rabbit and fox. And if we imagine that the bromine, the red colour, the intermediate, are the rabbits, provided there's plenty of food, the reactants, the rabbit population can increase and we get the deep red colour. That means there's then plenty prey for the predator, the fox, and the fox can come along, eat the rabbits, and the rabbit population dies away again. Hence, the foxes would die away, and provided there was still plenty of food, the rabbit population could increase again. And so this can go on over and over until all the food is used up, until all the reactants are used up, and eventually the oscillation reaction does die away. Although oscillating reactions aren't actually on the syllabus, they do make quite a nice way of perhaps getting students to think about reaction kinetics and the factors in affecting the rate of a reaction. And a good student project could be to investigate the factors affecting the time period of the oscillation. At the end of the demonstration, it's quite easy to dispose of the reaction mixture. Simply rinse it down the sink with plenty of water.